everyone. In today's video, we'll see how Dockers can be configured on a local machine. In this example, I'm going to use my MacBook to configure locally. However, even if you are using Windows, probably the steps will remain the same. The commands may differ slightly. In MacBook, we can download the DMG file and install it directly on GUI. Same way we can do it on Windows. You can download the Docker and just run the install wizard will configure Docker for you. In this tutorial, I'm just going to show you how we can do it from terminal, MacBook terminal or through command line. In previous video, you have seen Docker already. I've demonstrated how it works, how we can configure it on AWS cloud, along with some live code demonstration where we built some simple code on Python and deployed it on our Docker's containers on AWS EC2 instance. So for Linux example, you can refer to those video in the same playlist. In this video, I'm just going to show how we configure Docker locally on our machine. Now, why we install on Mac, right? So you have to remember one thing: when you install on Linux machine versus when you install on another operating system which is GUI based like Mac OS or Windows. So especially in case of Mac, right, the Docker binary is only a client, and you cannot use it to run the Docker daemon because the daemon requires Linux specific kernel features, and therefore you cannot run the daemon basically natively on an OS, especially like OS X. So you'll have to install something like Docker machine in order to create a virtual machine and then attach the virtual machine to your Docker installation. So let's see simply how we install. Now I could have done just brew install Docker. However, this will not work. Like I said, in Mac OS the binary is only client and you cannot use to run daemon. So if you want to do that, then I have to use hyphen cast and then I'll say Docker. Now what this will do is basically it is downloading the Docker DMG for me. If you see over here, it does nothing but download Docker DMG and it will install the DMG file through command line over here from the MacBook terminal and it will configure Docker. Once this installation is completed, I'll show you how we configure Docker and then we'll download some images and we'll also see how we spin up containers out of those images. Now all this will happen locally on my MacBook. Right. In previous videos, I've shown you how it happens on AWS, how do you install Docker. If you were to install the same thing on a AWS or a Linux machine, you just sudo apt install Docker. That's it. That simple it is. And in that, you can just configure your user to the Docker group, and that's it. You can start using it. In macOS also locally, you'll have to do similar thing, but in a different way, and I'll show you shortly. So we have our Docker installed now. Okay. Now, once it is installed, if you see, if I run this docker ps command, it will not work. You see, command not found, although I've installed it. So what we'll do is, we'll run docker, right? I'll launch the app, and if you see, if I type docker here, okay, I did not download it explicitly, right? I just downloaded using this brew install cask command, and you see it automatically downloaded this application for us. Now, once we launch this, it will ask you for certain privilege access. You have to grant those access to the Docker application to launch. Now, I'll drag it over here, and we don't need to learn. So you see, Docker desktop is starting over here. We'll give you a few seconds. It will take few seconds to start. Once it starts, and then after this, if I start running, there you go. So you see some images that is showing here. Now, once you, all right. So now if I give this command docker ps and there you go, you see it shows me the container ID, the image, command created, status, ports and names. Right now we don't have anything, so it just shows me blank. So this is how the Docker is installed on a Mac machine. Now let's see further how we use Docker and how we actually implement on locally on Mac. Install Docker. Let's see if the Docker is installed correctly and it's working fine. You can check the Docker version. Right. Now, if you see here, the Docker version over here, there's one thing to notice, right? It shows you both client as well as server. Now, if you would have done this on Linux, you would have required sudo, and then you'll have to assign permissions user mode to the Docker user, right? So you have a group Docker and your user. So unless and until you assign the user to the Docker group on a Linux machine terminal, you'll not be able to see the server. You'll only see the client version of it. So that's the only difference what we do over here on a local machine versus on Linux, right? You'll have to assign the user to the Docker group to start using both the client and server version of it. Now, for Docker, let's see the processes that are running. To check the processes, we can just use a simple Linux command, ps-ef, and we'll grab the Docker process name. Now, if you notice something, you will see that there is a Docker daemon ID, and also there is Docker child ID. Now, if you see everywhere, there is a daemon, there's a parent daemon, and there's a child running under it. And these are the process IDs for the daemon as well as the child. If you want to kill a parent process ID, it will not allow you to do that. We'll see that later. I'll show you a basic example of why we cannot do. That's by default, and Docker doesn't allow you, right? If somebody tries to go and kill the parent, you cannot kill it unless and until the child is running or killed. So these child and parent daemon together will use and consume all the resources inside the Docker. Together they will work and function and consume and allocate the resources that is required for Docker to perform. If I want to see what all images we have installed right now, so I'll just type Docker images. So you see there's a repository, the image name, there will be a tag, there will be image ID, the created date and the size of the image. Right now we don't have anything. Similarly, if you want to see Docker containers, we don't have any container as of yet. I'll clear the screen. Now let's see a simple example. How do we create images and how do we spin up containers from those images? What to do is I'll download a Docker image and I'll show you from command line how this is done. Now for that we'll use the command docker run. Now docker run means Docker is telling that okay, do this for me. Uh, Assume this, run. Like for example, in Java, if you create a class, right, you give a class and a class name. Let's say class name is XYZ, and then you want to create an object out of this class, and then you say new XYZ is equal to whatever the object name. So that means you are instantiating an object, a new object from that class. Run does exactly the same. So that's what the use of run is, and that's what we are telling Docker to do. Then we'll say hyphen hyphen rm. Now, RMS is a concept used for removing, that is garbage collecting the containers. That means I'm telling Docker, I'm instructing Docker that you spin up the image, you download the image for me, spin up the containers for me. Once the job is done or the process is complete, you garbage collect that container for me. That means it will not keep it inside this particular local machine. If you are doing it on AWS cloud, that means on that cloud. Right now we are doing it on a local machine, so on a local machine. So that is what we give hyphen hyphen rm. Now if you see on a Docker Hub, which are public images are available in Docker Hub, you can go to Google search for Docker Hub and then go to your Docker Hub and you will see a lot of images like Tomcat image, MySQL image, Cassandra image. There are a lot of images available. You can pick up any one official image and you can just try to download, install, create. You can create image, download image, whatever you can do it. It's up to you, right? Based on your requirement. However, here I'm not going to create, but remember, I'm going to use one simple image called BusyBox. Now, this is a very minimal version of some basic utilities commands for Unix. So I'll just say BusyBox, and then there's one concept in whenever you spin up a Docker image, it looks out for the latest version. If you don't provide anything by default, Docker will always look or search for a latest image of this busy box. Now remember one thing, you can explicitly mention over here colon latest. But remember one thing, if your image does not have any tag like latest or version name, that will error out. So you will have to make sure that you have configured your resource accordingly, your repository accordingly. If the repository does not have any tag like latest, then it will error out simply. Now let's say I want to run a simple command from that busy box, which is an echo command. And I echo say, hello, this is my first image. That's it. Now, the moment I will hit enter, it will search for this image. Which image? BusyBox. If it does not find this image, it will try to search the image on the Docker Hub. It will download the image for me. And once it is downloaded, it will spin up the container for me. So this is how it works. If I have it, it will first search in my local machine. or if it is the cloud, it will search in my local cloud machine. If it doesn't find the image, then it will go to Docker Hub. It will search for the image, it will connect to Docker Hub, download the image, and then it will spin up the container. And let's see. You see, unable to find the image locally, the latest. Now what it is doing is it is pulling from the Docker Hub. You see, you saw some layers getting installed. The pull is completed. It downloaded the image. Right? It was not there, and then it ran the command echo. Hello, this is my first image. You can see over here. This is the command. This is what I had given over here. So this is how it works. Now, if you go and see here, Docker image. Oh, sorry, Docker images. You see, this is the repository that we installed. This is the image. Repository is nothing but the image tag, and you see this tag latest. This is what I was referring to. If you don't have this tag, it will error out. So always make sure you have your versioning done. This is the image ID, and notice one thing, it shows 3 weeks ago, and we just ran this command just now, a minute ago. Why is it? This is exactly what I wanted to show you. We did not create the image, we downloaded the image, right? You see here, it downloaded the image. We did not have this image locally in our machine, so it was never existing over here. Now, because we downloaded, somebody, some entity, or some person, or whoever would have modified or created this version, this latest version, 3 weeks ago. So it shows us the same created date, and this is the size of the image. Now, next, let's see Docker containers. There are no containers. We'll say Docker PS. Let's say all. I want to see all, because in this local machine there could be many other containers. So -a is for all. Now you see there is no container. Why you if you notice, when I gave this command, I mentioned that you garbage collect my image, and then you garbage collect my container once the work is done. So once it completed this command, the container was dropped. It was deleted. There's this container does not exist. So that's why we use this hyphen rm image, and try out and see how containers look like, right? So let's say there's one more image which available on the Docker Hub. We'll use the same command docker run. This time now I'm not going to give hyphen rm, right? Because we want to see how the containers get created, right? In the previous example we mentioned rm. This next example I won't. Now what I'll do is differently over here. I'll mention the user as Docker. Under this user, I want to use a image called whale-say. This is available on Docker image. I'm just trying an example which I know and I have studied. Or you can try any other example, right? Under this whale-say image, there is a command called cow-say. Now this command, so like in previous example, what we did, we created we downloaded this image busybox. We used the version as latest, and then we ran the command echo, right? Inside that busybox, there's a command called echo. Here what we are doing is, we are downloading the image whale-say. Under that, but what we are telling Docker is, only download the image created by the user Docker, okay? Only from this user. So this image will be downloaded, and under this image there's a command called cow-say. You run that command, and in that command you will just say hello Docker, welcome. Now you'll see when I run this command, and it can't find it locally. First it searches locally. If it doesn't find, now it will try to download this image. Now you see it is trying to download several various layers. In the previous example, it was pretty fast in a blink of an eye. Here it is taking some time because it has some significant size. The image size is significant, so that's why it's taking some time. You see pull completed. Once it completed the download, it pulled all the image files, and once the download was done, it ran the latest image whale-say by default. If you notice, I had not mentioned anything over here in the command whale-say :latest like I had done in the previous command, but it still picked up the latest image. If you don't give any version, by default it looks for Docker looks for a latest image, and then it ran the command cow-say, and that command, the output of that command is hello Docker, welcome. It shows the image of a whale with containers on the top. Right now, let's see further. If you see now, Docker images, if I run this command, and now if you see, last time, previous example, we just installed busybox, which showed latest version. This was the image ID 3 weeks ago. Now we just installed this image whale-say. You see that also appears in the list. The tag is latest. This is the image ID 7 years ago. and the size is 247 MB, and that's why you were able to see visibly on the screen when it was trying to download the layers for downloading this image. Now let's see containers. So if you see Docker PS, it doesn't show because on this machine I want to see all the containers that are available, and now you'll see there is a container. This is a container ID. Under this image, this container is stored, right? I told you, right? I'd shown you the process, right? So that means you can say under this particular process, you have this another process running. The command that we executed, we ran this a minute ago, and you see the status is exited. So that means by default, the container, once the work is done, the job is done, it exits. Okay, it destroys the container, and you will see there's a name. It automatically assigns Sleepy Keldish. It assigns some funny names right by itself. You may choose to give the name yourself, or if you don't, then the Docker will by default give some names, right? Now you can either use the container ID or you can use the container names if you want to do anything with these containers. If you want to remove or delete or rename, whatever you want to do, you can use either the ID or you can use the names. Now, one thing you can do is if I say Docker RM and I want to remove this container, I can type the ID, but you don't need to type the whole ID. You'll see if these ID names are unique, you can just type the first character of that and it will automatically delete that. You see, it identified this 4. And now if you again run docker ps-a, the container is gone. So the beauty of this is if these names are unique, you just type the first character or the letter or the number, it will identify uniquely and it will delete that container from the list. Okay, but the image is still there. If you go to Docker images, the image still exists. We only deleted the container, not the image. Right? I hope so far you understood and we are clear. Now, where are these images stored in the local machine, right? If you were to do this on a cloud, on a Linux Ubuntu machine cloud, it gets stored somewhere in a path called, where lib, and then it is under folder AWFS, I believe. It goes under, let me check, I don't remember the path. Uh, okay, in that it goes under Docker, and then it has AWFS folder, and in that you will be able to see layers, all the layers that it installs. But we are right now on a MacBook, we are not on a Ubuntu or a Linux machine, so this path will not work over here. So in MacBook it is on a different path, and you will not be able to access that path directly, because what happens is in MacBook it is a hidden folder, but the path I can tell you, it is somewhere in where am I? I'm in, yeah. So I'm actually in that folder. Okay. So if you see under users, the username, library, containers, com.docker.docker, and data. Now, though, however, when I check here, so you will find all those images over here. You'll have to identify which are those, what images you want. But this is the path on a local machine in MacBook. In Windows, it will be a different path. I'm not sure about the path on Windows. You'll have to check. But you can identify the layers where it is getting installed. However, this was just for the knowledge purpose. Do not try to tinker with these images. Otherwise, you may end up, getting errors in your repository when you start running the processes. So never try to change or modify directly. If you want to delete the images, you can just directly go here. And when you see, let's say I want to remove this image and say docker rm. And this is the image I want to remove. So you can use the image ID. Let's say I'll remove this image. Copy, give the image ID. And no such. Okay, 1 second. But it is not Docker RM, it is RMI because you want to remove the image. So for image, you have to use RMI, I for image, and then you use that image name and it will remove. You see, it deleted all the layers that it had installed. Right now, if you go and check uh, Docker images, and now you see that image is gone. You see this one? Docker will say it does not exist. You only have BusyBox. So this is how you can delete the layers, the images, but never try to go directly on the folder and try to tinker anything there. And show you was that these containers are temporary. Remember, if you store any user data or your client, client data on a container, it will get lost or it might get lost. How this works is a container is within a Docker image, and your Docker image is within some EC2 instance or in some machine. Now, let's say in normally when you are in a cloud, you will have a auto scaling ability, right? So it will scale up and down depending on your demand. So if the demand increases, it will scale up, and as the demand reduces, it will scale down. Now, during that process, if it removes that EC2 instance, remember EC2 instance has a Docker image, and under Docker image you have your containers, and within the container you have your data. So if you go back, if your EC2 instance is gone or your machine is gone, your Docker data is gone, your images are gone, your container is gone. So be very, very careful of that. Containers are temporary. So that means all the containers are ephemeral in nature. So if you store anything in that, it will get lost. I'll show you, I'll demonstrate it to you right now in a live practical demonstration over here. But there's also a way out of doing that. On a very high level, you can try to explore that option, though I'm not going to show you this video. I want to keep it very short. There is a way where you can do something called as volume mapping. That means your container can actually write to your local file system. Okay, so you can do that. There is a way out of doing it. So that means your container will keep running, will keep spinning. So the first process ID of that container will be a process ID for that container that will never be killed or that can never be killed, and that will be a daemon that will continuously keep running. As long as that process is active, your container will remain active, and so will be your data. The moment that process is lost or gone or killed, and your container is gone, and all your data or whatever the client information you have, all your important data information will be lost. So let's have a look. So we'll go and look at the same example, same command, Docker run. Now this I want an interactive terminal, right? So interactive, I'll use IT, and I'll use same RM, and busy box, the same image we'll use again, and I'll say latest. Okay. Now notice here, I'm in an interactive shell because I gave -IT. Now, I'm not on my local machine, but I am in that container. I'm inside that container of BusyBox image. It will work like a normal, terminal or a Linux environment. It will give you an impression like you're under a Linux machine, but it is not. So if you create anything like, let's say, testing demo, okay, and then if you see, you will see that folder testing demo appear over here, right? You can do whatever command you want to run. You can say echo hello world. It will work like a normal Linux machine. However, the moment I exit out of this, okay, right, now I'm on my Linux machine. I'm back to my local MacBook terminal. Okay, if I go here and if I see Docker images and Docker container, okay, it's not there. You will not see that folder over here, right? The one that I created just now. Now, if I go back to that same, if I run that same command again, and if I go back to my container again, and now if I run ls, you will see that folder is gone. You see this? This folder which I had created, testing demo. I'm into my same image again, which I was running earlier. I had created this folder, testing demo. Here you can see it, but here it is gone. So you see the difference? If you are creating a container, that container will be only for a specific period and not permanent. So remember one thing, when you create a container or when you spin up a container, you have to make sure your data is not stored unless until you want to do a volume mapping and store your data and keep your container process active. Only then you should try that. Otherwise, you should not. One more thing to notice over here is if you see ps-ef, in this container, you will see the primary process ID one is your SH. On a Linux machine or any local machine, the SH is never a primary, process ID. If you spin up an image from a, let's say, Apache Tomcat, the Tomcat will be your first process ID. If you do for MySQL, MySQL will be your first process ID, and so on. So because we are into this shell, so shell is a process ID one, and that's what I wanted to show you. So that's all for this particular video. I hope you like it and you understood. If you really want a detailed demonstration, check out my other videos on Docker in the same playlist where I've demonstrated on AWS how you use Dockers and how do you actually deploy the code over there. All right. Thank you. Have a good day.